The other day, of course, I had to go to a bar, and I asked somebody, forgive my ignorance, I had no idea what Australia Day was, and he said, well, it's kind of like your 4th of July, and he was telling me some more about it, and I said, well, I'm not sure it's quite like my 4th of July. I think you're celebrating a British invasion, and we were celebrating kicking the British out, but nevertheless. But anyway, it's been great here in Australia, and I was talking to my wife yesterday, and she asked how it was, and I said, well, it's good, except I haven't seen any kangaroos yet. And on my way drive down here, I got to see one on the side of the road, so that was great. So. Anyway, let me get started. Oh, I'm sorry, this was my rejected talk. Move on. All right, so my talk is about defending Apache Hadoop using some trusted computing concepts. And I'm going to talk about the technology involved, a kind of an anatomy of a targeted threat, and some possible ways that you can countermeasure threats using trusted computing. Not as interesting as my rejected talk, but about the Death Star, but nevertheless. I work for HP. I'm here from Maryland, Baltimore area near DC, and that's it. So as I said, I'm a consultant do U.S. public sector consulting, mainly for Department of Defense. And I'm also a doctoral student at Towson University, and this is my personal research project. It's not affiliated with HP, but it's part of that program. So anyway, as I said, I'm going to go through some concepts, and I'm going to give a motivation for using trusted computing and some details of a Hadoop infrastructure that uses trusted computing, some possible software integrations into Hadoop code, and some preliminary results and some challenges. So when I was putting this together, I realized that it probably was a little bit of a niche topic, Hadoop and trusted computing. So my hope is that with this, you might get other ideas of how you could possibly use this technology and other applications that you might deal with. But if you don't know too much about Hadoop, I'm not an expert, but I'll give you a little bit of background. It's an open source software framework, and it's for dealing with big data, one of the buzzwords that we hear a lot today. It's a distributed computation framework, and it provides basically two frameworks, a storage framework called HDFS and a MapReduce framework, which is the application processing framework. And it works by distributing data across a network of commodity servers, and it basically allows for the storage and processing in a real efficient way. And for certain application domains, it provides a lot of advantages because it takes the processing to the data as opposed to bringing the data to the processing. So it gives some advantages over traditional setups. And it's essentially an open implementation of Google's file systems and MapReduce engine. It was described by Google in their papers that they presented in 2003. I already mentioned it has the two components. And there's also a number of other open source projects that make use of the core components. HBase is a big one. It provides a kind of a relational database view over top of data that you would store in HDFS. There's a number of other projects that go along with it too. And it's primarily written in Java. There's interfaces that you can program MapReduce, Python or other languages, but the primary software is all Java. And there's some commercial vendors that have picked it up. Cloudera is a big one. And they've tried to take this open source software, package it up, and make it a little bit easier to use. So the focus of this is, I'm going to be talking about HDFS in particular, because that's where the data is stored. And So a little bit of the technical details of how it works. You have a master-slave architecture where essentially there's one, or in later versions more than one name node that essentially stores a database of where individual chunks of data are stored within all your various data nodes. And when a client makes a request, it talks to a name node and it directs it to a data node to actually pick up the particular pieces of the files. So what it does is it essentially creates a virtual, the actual files are still stored within typically Linux file system, and then it creates this kind of virtual mapping on top of it. So the name node, it maintains this FS image as the name of it, and the data nodes keep copies of the blocks, and they keep a checksum of each block to maintain integrity. And they coordinate a replication, configurable, rack-aware replication so that you can create redundant copies of your data. Okay, trusted computing. So I'm going to go over this a little bit in case there's people that haven't heard of it. I know me personally, and working in the industry for, I don't know, about 11 years now, I hadn't really heard of it until a couple years ago. I went to a conference that the NSA put on about, some pretty cool stuff here, and why haven't I heard of it? And there's a lot of reasons behind that, it turns out. And there's been some historic kind of concerns about privacy, Microsoft's involvement, of course, and the NSA's involvement. So there's been a lot of roadblocks, I'd say, to mainstream adoption. But, and I'm not really suggesting kind of using this necessarily on your desktop. But when you're talking about a specific application domain, like Hadoop, for instance, there's ways that you can use this stuff to enhance the security of a particular application domain. So the Trusted Computing Group is a consortium. HP, IBM, a couple of other big players are involved in, and they basically are a standards body that is developing the specs for this technology that other companies go and implement. And kind of the core of it is the TPM, it's Trusted Platform Module. It's present in pretty much any server, laptop, or desktop you can buy, at least in the US. And it stores hashes and built-in registers that are called PCRs. They stand for Platform Control Registers. And they represent the state of the system at boot, and they reset anytime the machine's is rebooted. The spec calls for 24 of these registers, and the spec also defines what some of them are supposed to do. There's a lot that aren't. The idea of it is that you can attest the state of the system by taking these values and presenting them to a remote verifier, and they can basically determine if your system is in a state that they would trust. And it has another number of other features, monotonic counters and NVRAM to store cryptographic keys in. And it's not a cryptographic accelerator at all. It's quite slow, actually. It hangs off of I believe a low pin count bus that the keyboard's attached to. And it's about 100 milliseconds average response time. So it really limits what you can kind of do with it in a time-sensitive application. So it can store and protect cryptographic material via binding, sealing, or storage. And binding is encrypting to a key that is tied to the TPM storage root key. It's a key that comes basically burned into the TPM from the factory. And data sealing is basically you won't decrypt something unless your system is in a known state, and the known state is the values of the PCRs are in an expected condition. And it can conduct key operations inside the chip itself, so basically a rootkit or some system level attack can't compromise it. And there's firmware-based TPMs that are appearing, and there's a new TPM spec that's upcoming. And I threw this in here just to kind of show what they had in mind when they put this spec together. And basically, you can see that there's a local applications that can access it through kind of a layered approach. They have a TPM driver and a core services and a trusted software layer. And interestingly, on the scenario 3, you can also optionally connect to a TPM remotely, which is probably scary in some cases, but you know, for a controlled environment, it might be something that is useful. And also, for this in here has nothing to do with my talk, but this is kind of like golden grail of what one thing they're trying to do is trusted network connect. Basically, similar to other network access control technologies, except their idea is that they want to tie in databases from across the enterprise through this, they call it an IF-map interface. And the idea is that you can do geo-fencing and other things like that. And everything basically comes down to systems that have TPM, so the trust level is something that can be verified. And here's some of the open source components that are involved, that are out there that you can use in Linux, that can enable connectivity to your TPM, and so you can kind of play with it yourself. Trousers, I believe IPM was developed that. It's open source out there. It's a software stack. It comes in a lot of Linux distros by default, or you can easily install it. TPM tools allow for some basic things that you can do with TPM: take ownership, generate the keys, access the PCRs, and it provides an API that you can use as well. And then there's things that you can actually use to help secure your system, and Trusted Grub is one of them. There's actually a couple of versions of it out there. But the idea here is it's a bootloader, and it takes advantage of the TPM by filling in the PCRs with values that you can define. And basically, the idea is you want everything that is relevant to the security of the system in what you would call a trusted computing base. And that would be your kernel, maybe a initRD, certain configuration files that are relevant. And besides Trusted Grub, there's also tboot that uses DTRM, which is, so I should have said, Trusted Grub uses an idea of static root of trust, so everything is measured and it's passed to kind of a next layer which measures and extends these PCRs and into a next application layer ultimately. To implement, tboot uses DTRM, which makes use of Intel technology called TXT, Trusted Execution Technology, I think it stands for. So that's another option that you can use. And then at the system level, IMA is the integrity management, and EVM is the extended verification module. You can use, they, I think, mainstreamed into one of the 3.0 kernels. I'm not sure which one off the top of my head, but basically the goals here were to create like a independent kind of offline integrity management system that by using the EVM you can use the TPM to protect integrity management. Integrity. Yeah, lost my train of thought. Sorry. Basically, integrity values of individual files, and it's configurable. And also, after everything's handed off, you know, from Trusted Grub or tboot, IMA can take over to extend a PCR with everything that's opened by root, and that would be essentially the trusted computing base. And that's important because typically, if you have a server, you're not, you know, and it's up and running, that value should be pretty consistent because you shouldn't be logging in as root and doing things. So that's one way that when a system's up and running, you can verify that these items that you expected to remain consistent are still consistent. And they're complement to mandatory access control like the SE Linux and SMAC. It basically, as I said, it does a couple core things. It collects, it stores as an extended attribute. It can attest to it by signing that IMA PCR, and it can do a local appraisal against the database of good values. And it, as I said, with EVM, it can protect these hashes by encrypting them against a key in a TPM. And then lastly, open platform trust services. TCG put out a set of standards called platform trust services, and the idea was to so they tried to implement a attestation based on like a public key kind of situation where you would have to essentially trust a third party, and OpenPST was kind of a way to not have that extra overhead, and the OpenPST is kind of a beta thing that you can try out, and it essentially is a collector that you would run on the client and a server that has a verifier that you would have a list of hashes and PCR values that you would expect, and this can verify that. JTSS is a pure Java implementation of the trusted software stack, and it provides a way to access TPM through Java itself, and you can use it directly or you can use it with trousers, and you can also enable that remote connectivity that I mentioned earlier with a SOAP-based interface that it provides. So to get to motivation, I threw this kind of picture in here, and you kind of have this assumption that if, when you're implementing a cloud, that your internal environment is trusted, and maybe your external environment is not so much. And the key is how do you prove that? And this technology is a way that you can actually prove that. Now there's some serious kind of issues with implementing it, particularly in like cloud scenario where you have hypervisors involved, and because there's this lack of a virtualized TPM. But Intel, for instance, has been brought something out they call trusted compute pools, and essentially does a measured boot of the hypervisor, and it kind of at least gives you kind of the idea of that layer of your stack is intact. But going up from that, that still is an issue. So again, motivation. So strength of Hadoop is this, to distribute processing across hardware, and distribute it geographically, outsource possibly. And in certain environments, you might have sensitive data that the integrity that's built into the Hadoop, it might not be sufficient. So, and the security was a bolted-on kind of effort. In 2009, Yahoo group from Yahoo wrote a paper on implementing Kerberos as the kind of take care of some of the woes that they had with security. But even with that, there's still serious concerns, and the Kerberos, and it still is expected to be very isolated from your users and from your network in general. And part of the reason that they decided to do this, this security instead of maybe taking a different route using PKI or something, is they really wanted to maintain the performance of Hadoop, and they said they didn't want any more than a 3% decrease in performance. And here's some assumptions that the Cloudera security guide says to make for CDH3 is one version behind of the current one, but you can see this is pretty typical stuff for a security conscious organization, but it might not be practical assumptions under certain conditions. So it makes a lot of efforts to ensure that the data is safe for corruption and stored in a redundant fashion, but it can only be trusted to the extent that the people have access to it, and that's people officially or outside people are able to get into it. And basically, a Hadoop node compromised by a malicious outsider or insider could alter the data outside of any checks within the software. And so because of the fact that the files are stored physically on these systems. And and there's a lot of other attack scenarios, including replacing the Hadoop software itself with packages that do something malicious, like export the data out to some server on the internet, or corrupt it in some other way. And these might not be typical scenarios for an organization that is just using it for simple analytics or something. But if you have data there that's important, then likelihood is that somebody else might find it important too. And I'm talking specifically, in defense applications, healthcare applications. You could have a treasure trove of information that somebody could be interested in. And you're not going to have passwords or trade secrets or nuclear launch codes, but there might be other information there that somebody could be interested in. So I went through kind of a threat model. I'm going to kind of breeze through it. It's so there's ways that you can do data spoofing and Kerberos, in Hadoop. And one of the issues with the Kerberos bolt-on is it's actually really kind of hard to configure. It doesn't use it out of the box. Even like the Cloudera distribution, you have to do a lot of manual configuration. So basically, it begs to be left in an unsecure configuration, so that would leave it open to certain spoofing attacks. Even using Kerberos, somebody able to access the tokens that it uses can do hash-to-hash style attacks. Data stored in HDFS in the clear. It's not there's no option for encryption. In most versions of it, it's actually transmitted on the network in the clear as well. The most kind of recent version, they've added a authentication that based on Kerberos that also adds an encryption layer. But that's pretty much just brand new. And it had non-repudiation again. There's issues with that if you're not using Kerberos or even if you are. And so there's information disclosures issues and denial of service. Interestingly, there's a couple of issue reports out there about denial of service attacks with current versions of Hadoop. And again, it's based on the assumption that someone can't access a name node directly except for authorized administrator. And there's elevation of privilege issues as well. And then, of course, possible vulnerabilities in the HDFS code. Just kind of out of curiosity, I kind of looked into this a bit, and there's some issue reports out there, which is kind of good to see that there's people in the community that are trying to improve the security of it, as far as recognizing that there's issues with how the name nodes work, how the edit logs work, and even implementing a fuzz checker to kind of do automated security testing. So that's good to see. I ran a scan on the latest Hadoop distribution using a static code analysis tool called Fortify that HP owns, and it found a number of vulnerabilities. Now, to qualify this, I'll say that Fortify and any static code product will hit a lot of false positives, but you can see that with almost 200,000 lines of code, there's certainly possibilities of issues there. And the reason I bring this up is that you can have a number of protections within your infrastructure, and if you have a vulnerability in your code, that's a lot more difficult to protect. So I'm going to talk a little bit about advanced persistent threat. This is a kind of another buzz term that's come up lately. So they typically target individual organizations through very convincing ploys. Usually they go for like a spear phishing attack, and they're using zero-day software vulnerabilities. We've seen this kind of a lot lately. The Stuxnet thing, the RSA breach from a few years ago. So there's basically these nation-state hackers that are out there. If you're in the U.S., that's China. If you're in China, it's probably the U.S. And there's also these groups like Anonymous and whatnot that seem to be able to intrude into with impunity. So there's basically the traditional security mechanisms that we have out there, firewalls, IDSs, are really not working against these kind of threats, because these are real targeted, very directed, and they take their time. And this is what we're seeing a lot of. And they use a 7-step exploitation cycle. They do heavy reconnaissance. They try to make an initial intrusion. They establish a backdoor. Then they start trying to move laterally by taking and finding credentials, install utilities to help them, privilege escalation, and then they go for the data exfiltration. and figure out ways that they can stay on your network. So they'll figure out ways to set up backdoors, and some obvious backdoors that you might say, okay, well there it is, I'll fix that, and meanwhile they have some other place that they're exfiltrating data. I'll quote O'Malley's one of the chief contributors of the Hadoop design, and he said, the motivation for adding security was not really to defend against hackers because they're behind corporate firewalls and only allow employee access. And without disrespecting the basically these type of threats, you can't really depend on that. So I think that it really begs for an evaluation of ways to, not just HDFS, but data in general, if it's important to figure out other ways besides network-based and standard type of intrusion detection. And the reason that they can evade, some of these things, 0 days are not detected by antivirus, and your firewalls, you have to allow ports in and out so users can do their business, and they have ways of masking their traffic on top of these ports that are allowed to be able to exfiltrate their data without making any sort of obvious things known, steps known. So here's an example of a fairly, what I would call a secure implementation of Hadoop in a corporate environment. And basically the idea here is I've isolated my core HDFS and MapReduce stuff into a behind firewalls, behind a proxy server. I'm using a HDFS proxy to keep the users from being able to access the data directly. But there's usually other channels into the environment, and the Hadoop admin shown there, he might just SSH into them or go through a firewall directly. So in our APT scenario, he's going to be a target for somebody that wants to get access to that data. So APT would look for some easy ways to get in. They're going to scan your web portal. They're going to use a vulnerability scanner. Now a good setup is going to probably block most of this. They're going to try for unvalidated web input. And then if they were able to get in this way, they're going to start trying to move laterally through my proxy server and possibly just set up shop there and wait for data to pass by and collect it that way. If they're unable to access data that way, if they're going to move on to a social engineering style attack, and they'll go for somebody that has access through spear phishing. I kind of like the scenario as they have the resources that, if they know one of the administrators are going to a conference, they might present them with a free USB stick that happens to have some 0-day software exploit on it. And before you know it, they've created a backdoor into their corporate network, and it's happened. So as I said, there's very kind of hard to detect. All right. Yeah, skip that. So, all right. So I was curious if I could take some of the off-the-shelf trusted computing stuff, technology that I spoke about, and integrate it into my Hadoop IT infrastructure, and see if I can maybe have some semblance of defenses against like some of these more advanced threats. And so basically, this involved taking and implementing a simple cluster with trusted grub, Linux IMA EVM, and OpenPST. And we also use dmcrypt, and I'll explain how I use that later in IPsec. So to provide a trusted and measured boot based on the SRTM, we use trusted grub. And the idea is to make sure that you have known software values as you're booting the system. Now, trusted grub itself doesn't actually it doesn't care what those values are. It's just going to put them into a PCR and move on. So that's where later on you have to kind of use those PCRs for something to make it valuable. So I give a little diagram of what I'm talking about here. And I also showed a TNC-enabled switch, but that's still kind of out there as far as widespread implementation goes. Yeah, just some details of how Trusted Grub works. It fills in these PCRs that I've shown here with, this is kind of how it works by default. And then you can also provide it with a checklist that will have some additional things you want it to check. So for instance, you could have it check, so if I'm just worried about Hadoop, I would have it check my, my jar files, my config files and stuff for that, and extend a PCR with those values that I would check, I would use later. And then the IMA subsystem can kind of extend this after I get past the boot process. So here's kind of how the chain of trust works. Goes from, one thing I've left out here is that a BIOS that is, any kind of modern BIOS will also extend the PCRs with the value of the BIOS. And then goes to Trusted Grub, the IMA, PST, and then, then we could say, well, what do we do now? How do we use it in HDFS specifically? And there's a couple ways that came up with using this, and I'll kind of get into it here. So we were able to take the PCR values that we expected and use it to seal and bind a partition that was encrypted with dmcrypt. And that partition was basically just, so we know that we can't do software-based encryption without slowing it down by more than 3%. So, my idea is, well, at least maybe we can check and make sure that the integrity information is correct, because if you, so at least you could detect if it had been, data had been altered when it was offline. So it turns out that it's kind of difficult to do because of the way it stores the checksums with the actual blocks in the same directory. So with a little bit of fiddling, I was able to make this work. And essentially, we can basically protect these checksums via that loopback directory. And when the system's offline, if we were to modify a chunk, data chunk, then this would be detected as a corrupt file. And then also, I didn't see any reason that we couldn't protect the entire name node partition with software-based encryption, because these are much less intensive as far as you're not actually storing block data there. So we were able to do that. And again, if the name node was offline, you would be able to detect any sort of modification after the next boot. Well, you wouldn't be able to modify because it would be encrypted. And then set up IPsec tunnels between the nodes. Practical if you had a humongous environment, but basically we used the TPM to protect a key that was used for the IPsec tunnel that was only unlocked if our system was in a known state. And then lastly, I started looking into ways that I could possibly integrate the TPM right into the software stack itself and the software. And this is kind of a simplistic way of doing it, but it was kind of a proof of concept. So on the left-hand side, to kind of show how the data flow works. So you have these data nodes that you have these high-level HDFS code. It trickles. It's fairly well segmented down to a lower-level code that deals with actually reading and storing files. And the blocks are stored physically on the Linux file system with a block and a checksum. On the picture on the right, what I've done is taken that low-level code and I've altered it to do a couple of things. And essentially, each time a block comes in to be written, it will basically will generate a random AES key using the TPM for a random number generator. And then we'll encrypt the block with that AES key, and then we'll encrypt the AES key using a key stored in the TPM. We could use the storage root key or some other key, and that is then saved as a separate file that goes along with the other data. So, and then if that file is requested to be read, the same thing kind of happens in reverse. You decrypt the block key, and then you decrypt the block, and you pass it back up the chain. So ideally, you would want essentially the end user to be able to say, well, I want to encrypt this file because it's really sensitive, and they could select within the client or within the application that they're using to turn that encryption on and off. And that way you could choose if you want to deal with the performance overhead or not. And I've kind of already explained all this, so I was just going to skip it. Yeah, so the one issue with doing something like this is you have to protect, you have an basically an authorization key that you use to do operations on the TPM. You can configure it so it doesn't require any key at all, which is probably not a good idea. On typical use cases for using a TPM, there's a user present and they're putting in a password to unlock a drive partition or what have you. But in this case, we want it automated, so we have to figure out a way to be able to get that password into our application in a secure way. And then, in this APT scenario, we don't want, we kind of want to keep that protected, and that's kind of difficult. And the idea that kind of working around with is being able to pull that key from a server after an attestation process is done. It's like during the initial system boot, so we know currently the system's not compromised with a rootkit. It's probably pretty safe to send that key down. And then at that point, it's only going to be stored as a hash. It's in memory. And then the password, of course, should be also different for each server. So if a attacker was able to compromise one node, he would have to do the same process on each node to be able to actually do anything. So lastly, so challenges. There's a lot. I say that the TCG stuff, trusted computing technology, next to SE Linux and maybe women, is probably one of the more difficult to understand subjects in the community. So it's just a lot to get your head around, and it's also it's a lot of extra work for an organization that wants to set it up. So I don't expect to see real wide-scale adoption of something like this. But if you have a real specific type of environment that you're trying to protect, if it's in defense or healthcare, et cetera, it's something worth looking at, and to see how it might be used. I do expect the TCG technology to pick up a little bit. I think that they're starting to get a little momentum. Windows 8, as much as I hate it, they've built in a measured boot along with the trusted boot. The trusted boot doesn't use the TCG technology, it uses UEFI secure boot. But nevertheless, if a TPM is present, it will extend PCRs during the boot process. And they also have implemented like a smart card kind of interface to the TCG, to the TPM. And so there's a possibility that this might pick up. But I found that the open source software that's available is pretty immature. A lot of it hasn't been worked on in some time. And so there's certainly a lot of challenges. Things like if you wanted to use IMA, EVM, this was Fedora 16. I ended up having to rebuild the kernel from source. And I can do that, but a typical system administrator might not have that kind of skill to do. And and for pretty much everything, you got to do a lot of tweaking, a lot of intense manipulation of the environment to use. So there's some challenges, but I think that it's kind of an interesting technology that's out there. It's been out there, and I think it's a good thing for people to consider. Yep, and as I already said this, so I think that's it.
Okay, we'll take some questions. If nobody else asks one, I will. Okay.
All right.
All right. One of the hot topics in distributed computing these days is data deduplication, or dereplication. Deduplication.
Right.
So how would you see data deduplication in a distributed integrity environment?
Well, Yeah, it's kind of a hard question. I think that I think that it's not necessarily. I'm not sure how tied that would be, but I do know that from what I've seen kind of at HP, a lot of organizations are starting to use Hadoop as a dumping ground. And I think that maybe it's because they don't really understand what it's for or what it was supposed to be for. So they're kind of using it as a catch-all for anything they might think they could possibly use at some point. So typically I'd say that this should be considered like a data warehousing environment. So, I think that it's probably okay to have redundant data and something like this, because what you're supposed to be using it for is to do analytics on not stuff that you're trying to do real time. So I don't think it really answers your question, but that's all I have.
Okay, that's fair.
Yep.
So, we have a question back here. So,
What size cluster Hadoop?
What size Hadoop cluster have you rolled this out on, and what's the underlying OS?
Sure. Yeah. This is just a little pet project, so it's only on a simple 2-node cluster with another node that's a OpenPST server. So very very simplistic kind of initial, just see if I could do it kind of thing. I would expect if you try to scale it, you're going to certainly have some issues. The way that the static root of trust works, and with the OpenPST verifier, is that you have a database of these values that you trust, and if you were to go and update any software on those systems, you have to go and update those known values as well. So you start scaling that big time, it becomes kind of something you'd have to plan as part of any sort of upgrade to your system, I guess. Yeah.
Next question.
G'day.
Yeah.
What sort of security architecture changes would you encourage the HDFS and Hadoop project in general to adopt? Obviously, you've identified that it's not particularly it's just banged on the side and with Kerberos. What would you suggest they do to enable everybody to have a safe HDFS, a safe MapReduce set of servers?
Right. That's a good question. And I'm certainly not criticizing how they designed the security, but I will say that they made assumptions about how you would typically use this in your corporate environment. And even if you work under those assumptions, I guess all I'm trying to say is you still can't be sure that is a safe environment. Even if you implement this, I'm not sure you can be 100% safe, but it certainly gives you a whole nother kind of layer of complexity that somebody would have to break through. And so as far as the actual source itself, I think that they should evaluate how they're using Kerberos in it. I'm not sure that, from what I kind of understand of how the ticketing system works. So it will essentially, so when a client comes in to authenticate, it passes request to a Kerberos environment, and it says, okay, you're authenticated. And then from there on, the Hadoop software handles the authentication between any sort of data node you need to go to via what they call delegation tokens. So in order to do this, they have to basically store a bunch of symmetric keys for the time that ticket's good for, which I think by default is like 24 hours. So it leaves kind of like a big window for those tickets to be compromised and pass a hash kind of thing happening with them. So some of that, I guess, could be done through configuration, but I think maybe a look at how the ticketing systems work is some, and I know that they wanted to maintain the performance, and that was paramount, but I think it would be kind of, and I think they're kind of going this way. They've built in like this SASL framework for in-transit encryption in the most latest version, and somebody should be able to decide for themselves whether they want to take the hit on the performance and have the extra security.
Okay, next question. All right, well, thank you.
Yep, thanks.
Okay, so